Let's go to Liquid 1849, split a string into descending consecutive values. Give us a string that consists of only digits. And let's check if we can split S into two or more non-empty substrings, such that the numerical values of the substrings are in descending order. And the difference between the numerical values of every two adjacent substrings is equal to 1. Um, Return true or false. Let's look at the example 2, right? So we can split this string into three parts: 0, 5, 0, 0, 4, and 3, right? So 0, 5, we need to change to numeric. It is 5. We can get rid of the leading 0, and 0, 0, 4, it is 4 and 3, right? So we'll see this is in descending order, and also the difference is 1 between two adjacent values, right? So it will return true. And example 1 and 3 is not able to have such a split. So let's look at the range. The string length is small or equal to 20, right? So we know this kind of uh, length range is very small. We can consider using backtracking, right? So when we are trying to search the split of position of a string. So the backtracking, for every index, it has a choice to split or not. So that will be, we'll see if we write DFS or backtracking, the time complexity will no worse than 2 to the power n time complexity, right? So we know we should be able to do backtracking. Actually, for this question, because it has so strict constraints, the time complexity is not 2 to power n, but it is n power 2. We'll analyze this a little better later. So we want to return true or false. So the first, we know the first, we should iterate the first numbers, trying to see with our DFS, we can have a count, right? Count values. So we need to have, for example, have an index equals to n, and also count greater uh, than 1, it will return true, right? And if we don't have want to pass in the count value into our DFS function, we can trying to iterate the for loop, trying to get the first number out. Then for the rest part, we do DFS, and so that we can get rid of one of the parameter in our backtracking function. And so what we do is that we use a for loop, right? For loop for I index I equals to 0 and I smaller than s dot length minus 1, right? Why it is small, minus 1? Because we want to have at least an empty string after the first string, right? So we get the first string out. And then for the rest part, we DFS. So rest part, the exit condition is that our index will be equals to the string dot length. And so what is the DFS, the the inner function, right? That is we trying to have a current, we need to pass in the index, then we trying to iterate in I from this index to length, right? Trying to find the iterate the separation index. But the thing is that when we're trying to iterate the separation index, we have only one single choices. That is, this separation is determined by the previous value, right? So if the separation, for example, we have iterate the first value to be 5, right? So that means the second separation can only be 4, right? So if it is greater than for example, 43, we should exit. So that is a unique separation for the next, right? So for the child, we'll say it is there is no branches, no other branches. So that is for our DFS. So it will have a unique connection when we go to the child. Um, so this chunk of the branch chunk can actually get our time complexity to be O(n) square because if we use the first for loop for the first value, then the second one, right, they will not go back. So we have only one choices. So for the inner for loop, they will never have some other choices. So that means those kind of index, if we bit, we cannot have score other branches. So we'll say the time complexity will be decreased dramatically be O(n) square time complexity. So the um truncation condition for the DFS is that we look at the value for our I, right? Trying to see whether we need a DFS should have for example current value, right? So we need the next should be, if it is integer, should be current -1, right? So let's write code for this. Let's have int n equals s dot length, and so we'll see the length is smaller than 20, right? So we can use long value t equals to 0, right? And then what to do is that for int I equals 0, I smaller than n minus 1, right? Why it is smaller than n minus 1? Because we want this one has at least two parts, right? So we are trying to get the first part number out. The good thing is that if we do this way, right? Get the first number out. For the first way number, there is no previous numbers, right? So that is another advantage is we get the first number out. Otherwise, if we have want to have the first part uh, also in the DFS part, we should try to see whether index equals to 0 as a special case, right? And also add the counts in the final exit condition. That get code a bit humble, right? So we'll write I plus plus. So then we're going to have t equals t multiplied by 10 plus s a char at minus 0, right? Here, there we can have another optimization here. So because we know the length is 20, right? So we'll say if this t is already greater than actually that means if this t is already greater than for example 1 0 greater than 10 zeros, right? Then that means if this t is already in 10 zeros, let's have mm, let's have possibly have more, right? That means that rest part 11 zeros. So the length will be for example, this is 11. The rest part will be length will be 9, right? So that means it's impossible the first number will be just one number greater than the second number, right? So we can just return false, right? Mm, we can just mm, break, break. We don't need to iterate the rest index because it's minutes. It's impossible. The next number will be just one smaller than t, right? So just we'll say if DFS we're going to pass in this kind of string, and also we're going to have I plus one, that is the next start index, and this is current value, right? This current value is actually because we want to see the next. So the truncation when we condition will be when we iterate this kind of index from I plus one, the next value will be this t minus one, right? We just return true. Otherwise, we just return false. So for our DFS, we're going to have a return value boolean, and we have a string s and int index, right? And a long current. So because we already have one integer t outside, right? So that means we can write safely here if index equals s dot length. We just return true, right? And now we're going to have long next equals 0l. And what we do is for int I equals index I smaller than s dot length I plus plus. So we're going to have next equals next multiplied by 10 plus s dot char at I minus 0. So the condition is that if next equals current minus 1 and the rest DFS return true, right? And the DFS s I plus 1 next, then we return true, right? And also we'll write if next is already greater equal to current, we should break, right? And in the end, just return false. So this will be the DFS code. It will be ON square time complexity. And the DFS will see it will be worst case will be backtrack. The stack depth will be n, right? Will be ON space. Let's also write Python code for this. So that means that we'll see this time complexity is ON square. But just a general case for DFS for partition, right? So sometimes will be 2 power n. But this one, because we'll see there is no the every child branch is deterministic. There is only one child. So it is O n squared time complexity. Let's also write Python code for this. We're going to have n equals the length of S and t equals 0. So what we do is for I in range n minus 1, we're going to have t equals t multiplied by 10 plus ORD SI minus ORD 0. So let's say if t is greater than, for example, let's have one more, right? We just return false, so that we can terminate early. And if we need a DFS self dot DFS si plus 1 t, right? Just return true. And when we jumping out this, we just return false. And our DFS function is going to return a true Boolean, right? So we'll say if index equals the length of S, we just return true. And we're going to have a next value, right? That's 0. So for I in range index and length S, right? We're going to have next value equals next value multiplied by 10 plus RD SI minus RD 0, right? So we'll see if next value equals current minus 1 and self dot DFS SI plus 1 and next value. If this is true, right? Return true. And we can terminate early, right? So if we don't terminate early, it will not be to the power n power 2 time complexity. It will be degree to n power 2 power n, right? So if n next value is greater equal to current, we just return false. And then when we jumping out, we just return false. If n value equals n value